Hi everyone, my name is Amit Varma. I'm the Chief Executive of Braintoy. We are a Canadian AI technology company which is based out of Calgary. Thank you so much for having me at the AI Expo Africa. It's a pleasure to be with professionals who are focused on automation and AI. I remember coming to South Africa once. I was at the Nelson Mandela Square and I really enjoyed being there. As a child, I remember I signed for a petition for Mr. Mandela's release. It's a pleasure to be speaking at this conference today. The topic for the conference is the reason why your snowflake AI projects will fail. Let's come to that. Now, before anything, I wanted to introduce Braintoy. We are a team of about 12 people. We are based out of Calgary. And we were born with a lofty objective: make AI accessible to everyone. Well, everyone knows that AI is so useful. It's used in every industry, every facet of life. It makes our life so easy. But why is machine learning so difficult? We were grappling with this problem and we face the same problem in our careers. It takes a long time. It is expensive. It takes a lot of skills and a different variety of skills. With that, we started Braintoy. We want to make AI accessible to everyone. Now, everyone in this room already knows a little bit about machine learning, AI. I'm very sure that most of you have built a model. Now, I've been in the industry. What I realized is most machine learning stops at a presentation stage. You build a model, you publish it, test some results, everyone sees the RMS score, you make a nice presentation, and that's where it stops. Why are models not deployed to production? Well, that's production machine learning. Production machine learning is not about one-time experiments. It's about repeated production. Producing models again and again, consistently, repeatedly, transparently, all well documented. I'm going to introduce production machine learning by citing the example of one of our clients. It's a Canadian AI company called as Two Hat Security. It's a tech company that's based out of British Columbia, and it uses an AI-powered platform to moderate content. So, for example, on YouTube, if you upload a video which has inappropriate content, it's going to be flagged. Similarly, on Facebook, if you go and you put a comment with a foul language, it's going to be moderated. This is all done through machine learning. This company has a team of some of the best developers and data scientists in the world who develop machine learning models to automate this moderation. They build hundreds of customized models to filter out negative and build on the positive. You can imagine one of the models tracks hundreds of languages, another model tracks profanity within one of the languages. The requirement was that this company had an inconsistent data scientist driven pipeline, and with more analysts joining the team and with more data capabilities, they wanted a solution that was consistent, scalable, and accessible to the entire development team, and not just data scientists. Now let's draw out their problems on a diagram. You see the slide in which there's so many boxes. Well, this is actually the entire production machine learning life cycle. You start with configuration, you have to ingest data, do feature extraction, verify the data, build some ML code. There's a bunch of tools which you use to track your progress. Then finally you build a model, you have to provision a machine, do all the API integrations, host it on a virtual machine, and then learn to monitor and tune your models. As models change, this whole cycle repeats again. So you can imagine that Two Hat had a problem with the model creation pipeline. This is what the pipeline actually looks like in most companies. Every data scientist had a unique way of getting things done. So, what they wanted was something that would consistently unify the model creation process across the company. It was struggling to handle different customers, different models, manage some of the custom models. People used to email their engineering, hey, here's a model, deploy it. Well, which version is deployed, when to swap? They explored many options. There's a lot of tools that are available from, say, Microsoft, Azure, Google, AWS. They all provide every one of these segments, but these segments are fragmented solutions. They are not as unified. These focus on building one-off models. So you can use all these tools to build a model and deploy it. Well, what happens for the next model? You start all over again. Two Hat realized this would be very, very time consuming. The process could be made easier with, say, adding more people, but no company can afford to just keep on adding people. And these people are expensive. They are not like, people who can be hired at a very low cost. Well, to add more people means millions of dollars of budgets. The team's frustration was growing. I still remember I read something from Lisa, who's the director of data science. She said she's going to be so happy when she can never have to use another conversation about what version of the model was deployed, because now she knows what exactly was deployed. It was time for a change. And changes were primarily because of two things. One is they were expanding their team. They wanted to hire business analysts, other developers, and they didn't want their tools to be very, very data scientist specific. Second is they wanted to produce lots of models. It wasn't about producing one model or two model or 10 models. For each product, they might have 500 models working together. Something had to be done. What Two Hat wanted was a model factory. Well, they had to enable a streamlined machine learning DevOps, which was something that was impossible with other tools like SageMaker and Azure. These tools are okay for building one models, but it's not practical to build machine learning at scale using these tools. Any of these tools, when they treat models as kind of one-off elements, it's just not possible to build models at scale. So they came to Braintoy. And now let me show you a demonstration of the MLOS, which is Braintoy's production machine learning platform. What you're going to see is a model factory in action. It will start with ingesting data, building models, reviewing models, deploying models as real-time apps, and then interacting with those models to get your real-time predictions.
Let's start by going to data engine, and we'll just go to load data, and we will load this data called iris by just clicking on it, and it's going to be loaded here. So I have already loaded that data, and so you see it here. I can click on iris to view it, and you can see it has these four features, and this is our target feature, which is species. That's what we're going to predict. So this is it, and we can interact with it. The first thing you want to do is you want to understand the data at a glance by just taking a look at it. So you can see that every feature in the data is listed here, and the data type of that feature is listed here. This is also the descriptive statistics and other necessary information about the data. For instance, how many observations are in the data? How many are missing? How many are unique? What's the maximum, the minimum, the standard deviation? What is the data type? And when I select a feature, automatically you can also see that the distribution of that feature is generated and shown to me in a bar chart. Another chart is also shown to me in a line graph. And so through this, you can walk through all the features that exist in the loaded data or the loaded data that you are going to work on, and at a glance you can see how this data looks like. The next thing is now you want to analyze the data. To understand the data, you also have to see the relationships that exist between various features. And so analysis is usually that, where you plot features against each other to see or verify the relationships that exist between them. In MLOS, it's as easy as selecting one of the features as your x-axis, it shows up here, and then you can select another as your y-axis and you say updates chart. Now you can add other features as y-axis, and so here I added sepal length, and let me just add another one called the sepal width, and I say update chart, and you can see it here. You can also change your x-axis at any time, and so I'm going to change it, and then I'll change this as my y-axis, remove that, and I say update, and this is how it looks like. The next thing is I want to now wrangle my data. Now wrangling your data comes with so many pre-built algorithms that can let you do so depending on the data set you're working on. So here we'll walk through this, but before that I would also show you this, which is customizing or adding your own custom wrangling algorithm or functions. This in MLOS we call it giving you control. So as you can see, with these automated functions here where you can plot and understand, and other automations that you will see, you can build models really fast. But you also need control, which means you also need to be able to customize them or add your own functionalities to them. And so in MLOS, if you want to add your own functionality, it's just a matter of clicking on this new code block, and I'm going to give this data a name, and I'll call it maybe iris wrangle as an example, iris WR. I say save. As soon as I click on save code block under custom, I will see this iris wrangle here, and I click edit code. Edit code takes me to an advanced code editor, and then an automatic a file has also been created for me, and the name of that Python file is the name of the function or the algorithm that I wrote. You can delete missing values, you can work on missing values, replace them with a value which is called imputation, and so on and so forth. If you're working on text data or natural language processing, there are pre-built-in algorithms that you can add. You can also add your own. If you want to do time series, you can also do univariate, multivariate time series, select your lag, select the window size, and so on, and you will be able to wrangle your data. So with this, you can be fast and you can also add your own. Now, when you have applied certain steps to your data set, one of the things here is that you can save them as a recipe. So saving them as a recipe is a matter of clicking on save. You can provide this as a name, and I'm going to call this Irish recipe as an example, or let's just say my recipe. I save it. So the next time I am working on this data set or anything similar to it, and I don't want to do these steps, or I don't even remember what I did, it's just a matter of opening here, selecting my recipe. I see all the things that were done. I'll select them. Here they are, and I can say apply, and it's going to apply them to the data set the same way. When you finish wrangling your data, you can preview it. Now, the next step after you've wrangled your data set is you want to define your data, which simply means that you select that data, whichever one you want to work with. It's either this one or the one that was wrangled. Yeah. And so, but let's work with this one just so that we can be fast. And it's just a matter of selecting what your inputs are. So these are my inputs. I'm going to use all 4 of these as my inputs, and based on this, we're going to predict a target, which is the species. And then maybe you want to do some feature pre-processing. Now, feature pre-processing is important because algorithms understand data well, or they learn well when you pre-process your data. It all depends on what you want to do. So for this, in MLOS, you can pre-process data on a single feature or on an entire data set. So for this one, just so that we can see the difference, I'm just going to apply to only 2 of the features. So I chose sepal length, sepal width, and I'm going to scale them. So I say standard scaling, and I say add to step. What standard scaling is going to do is that for these features, it's going to normalize them such that or standardize them such that the standard deviation will be 1 and the mean will be 0. The next step is that we should split our data, use a certain percentage of it to train an algorithm, to train a model, and then we'll use the other percentage to validate or to test it. And so the default is 80-20. I'm just going to leave it that way. But if you want to change it, you just use the slider and you can change it. It's just up to you how you want to split the data. So let's leave this at 80-20, and I say generate data set. And so my iris data set, or my iris data set, is going to be split. And now I can see that the split is complete. And when I click on it, you can see the difference. The species has been, or our target has been changed from categorical to numeric. And then the sepal length, sepal width has been scaled. And then the petal length and petal width are just the same. So now you can see that whatever we did was applied. So now let's move on. The next step is to create a model. And so you can click on next to go to the ML engine to create a model, which we'll just do like this. Or you can come here to the desktop and you can double click on ML engine to create a model. So in ML engine, you either create a classification or a regression model. The data we are working with is a classification model we're going to create because it's just categories. So we just say add base model. I select the data set, I select iris data, and then I will say, let's say my iris model as an example, my iris model, and then I say select data set. Automatically I am shown these algorithms. The algorithms have been grouped into categories. General purpose classifiers are general purpose classifiers. Random forest, multi-perceptron neural network, decision trees, the usual suspects. Deep learning are deep learning algorithms. So you have convolutional neural network, you have TensorFlow, but we also include other frameworks. So there is TensorFlow, but you also have PyTorch. TensorFlow from Google, PyTorch from Facebook. And then there is a combination of convolutional neural network and LSTM, long, short-term memory, etc. So it's all up to you. There is also natural language processing, NLP classifier, and you also have custom here. So just like you can add your own feature extractor and you can add your own data wrangling algorithms, you can also add your own classifiers or algorithms or regressors, learning algorithms, and I'll show you how later on. So for now, let's just select one of these algorithms, and as soon as you select, you have access to the parameters that you can tune for this particular algorithm, and by default it's also populated. For now, this is the only one that is highlighted, which is the number of estimates, but you can also select other parameters and make changes to them. But let's just move on with this, and we say create model. It's going to create a model, it's going to evaluate them, and it will show us the accuracy of that model. It will also show us other performance metrics. So random forest is 96.7%. This is the version. We can select it, and there it is. Now we can also create other models by just going back to change the algorithm. We can select another one, let's say extra tree classifier, and we can say create a model. But what if you don't know what algorithm to select? And some people don't, or maybe you just want to be fast. And so you can hit this autopilot button, and autopilot will use various algorithms that are suited to learning from the data sets that you have created. And it will create different algorithms. It will evaluate them. It will rank them on this leaderboard. It will have different versions of them for you. Now, the next step is that when you have a model, you have to deploy them. But before you do that, you want your machine learning models or application to avoid unintended consequences, which means it's always good to govern it or to get a second eye on it, a model risk manager or whoever, or your peer, to just review it. To do so, you also have to provide them with documentation of how the model was created. And so here in MLOS, that documentation is also done automatically for you, and you can see that by clicking on Doc. here, and it's interactive. And we'll talk more about this as we move on to the next step. So this is very important for the next step. And the next step is that now we're going to publish our model and get a peer reviewer to take a look at it before we put it in production. So let's select this random forest model, which we think is good. And we can choose to upload any information. I don't have any information to upload, but you can do that. And you select who you want to review. I'm just going to publish this to myself, just for demonstration purposes. Ideally, you have to share it with someone else. And so you can add any comments here, and then you say publish to reviewer, and the model is gone. And even view this data by clicking on it here, so you can see this is the target predicted, this is the target original. Now, every model that is created is an app in MLOS. And then let's select the app. So to deploy, you will just say use this app, which is my app. Click use this app. You'll say use this model. Select it. Say generate code. And then you say deploy. Now, there are two ways of deploying. You can deploy as a microservice directly, which means you can talk to it directly and you can start making decisions in real time or even in batch. Or you can deploy the complete Docker image as a package. Now, when you have created a model, you need to be able to test it. And usually, like we said, this model was deployed as a microservice. To test it simply means that you have to interact with that API. Supply some raw data, and then it will make a decision. And there you are. You can see we have the inputs, and you can say predict. Once you predict, you get the response. This is directly from the API. And I can change some of these values. I don't really know, which one is, but let me just make some changes and see what happens. So let me just hit it a couple of times too. I hope it makes sense, and hit it a couple of times, and I hit about 16 times now, and see each of them has been successful. Every time I hit it, you will see that the API response time changes. So see, 184 milliseconds is what it was to call that API and to make a decision. So this is virtually about the model.
So what you saw in this demo was a model factory in action. Remember, it's not machine learning. Machine learning is the simple part. Anyone can make models. It's about taking the data, cleansing it, building a model, deploying a model, having the whole lineage of data protected, and making sure that it's a repeatable process which runs like a factory again and again and again. So let me summarize. What is production machine learning? Production machine learning is 1. Repeatable. You should be able to do it again and again and again. It shouldn't be like, oh, I built one model, but I just can't repeat the process for a new model. 2. Production machine learning has to be governed. The documentation has to be there. If one person leaves, the other person should be able to take over, consistently build models. The model reviewer has to review the model for biases before deployment. 3rd, it's got to be easy. Easy means it should be useful to all the types of skills in the team. There are business analysts, there are cloud developers, there's data scientists, there's model reviewers. Everyone should be able to use it easily. With that, I'm going to end my talk. Thank you so much for having me over today. And if you want to visit our website, please visit braintoy.ai.